All right, so we'll get going here. This is, so you guys are gonna have to sit here longer if you do this. All right, so this is Econ 371. I'm Professor Lannis. So today we'll pretty much be going kind of through the syllabus. We'll start kind of introducing some content. I'll show you how to use a program that we're going to use all semester called Stata. I'm a little worried because I think we're about 10 people short. Hopefully that doesn't persist throughout the semester because attendance in class is going to be very important to being successful in this class. Also, I don't love this room design. It's probably going to be best for you because I'm going to be doing a lot of work that you're going to want to see on this screen to kind of sit more towards the middle as opposed to kind of on the sides. So just kind of a note moving forward. It might make it easier for you. So we'll kind of start with, I've got this Canvas page. You should be able to see the syllabus. We'll kind of take a look at bits of it today. I kind of summarize it in the slides. I have some files here. I put week 0. These are not assignments. There's just going to be some help files that you might need, and I'll kind of explain them here in a little bit. Week 1, I've got the syllabus, the slides we're going to work through today, and then some files that we're going to use when we look at this program called Stata. Okay, so we'll just dive into it here. And you might notice I've got Zoom running in the background. In fact, let me see if I can get this to go way down here. So I'm going to record every single class period. I'll kind of explain why here in a second. But basically, kind of what do you care about? There we go. Is kind of how you're graded, kind of what the expectations for the course are. So we're going to be using a book, Stock and Watson. I have to assign a textbook to this course. I'm not going to assign anything out of the textbook, right? If I were you, hopefully you haven't already purchased it. I wouldn't even necessarily purchase this book. And if you do, I'd look for an older version. You can probably find an older version for almost nothing. And it's really going to be the same thing, right? To tell you, behind the scenes, a lot of these textbooks get updated. They try to keep them relevant, but it's also just a way they can charge more money for the newer edition, right? So I don't assign anything out of the book. It's a good kind of resource, right? If you want to kind of, although I think if you probably Googled, you could probably find older versions as a PDF downloadable online. I probably shouldn't be recording this and posting it to YouTube, but I'm pretty sure you can do that. One thing you will need to do, we're going to use Canvas. I'll do some in-class quizzes. So you will need a laptop, a tablet, or a phone to access Canvas while you're in class to do those quizzes. And I'll talk more about them in a second. Also, when we work in Stata, we're probably going to want a laptop, right? If you have one that you can work on, work alongside of me, that's going to be pretty important to have in class. When it comes to the exams, we will be doing nothing more than addition, subtraction, division, multiplication, and maybe taking things to like the second or third power, right? So you shouldn't need any wild calculator, like a graphing calculator. All you're going to need for that exam, and what I will not let you have is a graphing calculator because you can also store notes on it, right? Is you just need a basic kind of 4-function calculator. I say for the exam, we'll have a midterm and a final, just a non-graphing calculator, okay? Should be more than you need. And then every single week, so this week's a little bit different. I just posted the complete version of the slides. After Thursday's class, I'll post next week's slides, right? What we'll cover next week. I always post what I call a skeleton version. I leave some things out, some things that we'll kind of work on that I want you to see ahead of time. And so I'll kind of post those prior to us going through it in class. And then at the end of the week, after we've covered that material, I'll post it up a completed version of the slides. Now, I do a lot of work. In fact, I probably should have this pulled up here. I don't think we'll really use it today, but just in case. So a lot of the times in class, what I'll do is I'll kind of go from the slides, there we go, to kind of the doc cam. All right, well, I'll write some things for you that you're not going to get in those YouTube recordings. So even though I record every single lecture on YouTube, you'll have the audio file. There's technical issues. Sometimes things go wrong. In fact, this isn't working today, so I'm probably going to try to bring my own webcam just to capture the audio a little bit better. I walk around. I'm not always trying to make sure I face this. I am not thinking about Zoom as I do this lecture, right? It's more of a resource for you that you do have some of the audio recorded. If you want to go back, oh, I know he said something about that. Or as we start to walk through Stata, it's going to screen capture what we do there. You can always go back and kind of reference what we did in class. Okay? Now, anything I do on this dot cam, it won't record, right? So anything that I do here is probably something you want to do what? Write down or take notes on, right? Because you're not going to be able to go back and get that, okay? So we'll kind of do that throughout the semester. I'll kind of bounce back and forth in between. Now, any recording that I have of the class period, and occasionally I'll throw up some additional help files. So for instance, here's our YouTube playlist for this class. It's where I'll post all the videos. I don't create any links on Canvas just to not muddy up the site too much. But if you ever go to, you can use that link. It's in the syllabus as well to that YouTube playlist. But you can also go to YouTube, search Professor Lantis, and I should be the first one that pops up. You would only be able to see kind of my 3 active playlists. Here, I only have one section of 371. So I actually already have a video up here. So I'll walk through some of these steps today in class, but here's like a more succinct and summary of the steps that you would need to download and access this program we're going to use called Stata. So that video is already up there. After class today, when I get back to my office, I'll post today's lecture, right? And kind of that's what I'll do every single class period. Okay. Also, I have a tendency to talk, especially this first class. If you ever have a question, make sure you stop me. Raise your hand. I want to try to get through some of this easy stuff kind of quick. You guys are already, primarily juniors and seniors, going. You can probably read the syllabus yourself. A lot of this is stuff you've kind of already heard before. So how are you going to get the grade that you want in this class? So 60% of the grade is going to come from exams, right? So 30% for the midterm and then 30% for the final. So the midterm exam is about halfway through the course. It will likely be, I won't guarantee this yet, there'll be an in-class portion. I often for that midterm try to separate it into an in-class portion and then a portion that I kind of create on Canvas, like a Canvas quiz, but it's a Canvas part of the exam. It's usually not worth as much of the exam as the in-class portion is. Sometimes it's like an 80-20% split there. But you might see for that midterm, I do some of it in class because we don't have quite as much time as the final, and then I'll do a portion of it on Canvas. Okay. That final exam will be, I don't think I have the date here. Let's see. It's in the syllabus. I think I have it on a slide later on. But that final exam is an assigned kind of time that the university gives us. It'll be a 2-hour time block, and those will be the 2 exams that we have. Okay. They're primarily open response, so not kind of these easy intro courses where we're doing like a lot of multiple choice questions. A lot of this is going to be kind of short answer. Okay. And I'll give you some practice exams as we get closer to those, and you'll have a better idea of what those actually look like. I'll also give you pretty much bi-weekly Canvas quizzes. So every 2 weeks, it'll be over the last 2 weeks of material that we've covered. So you'll expect those about every 2 weeks with, kind of a gap of an extra week when we have that the week for the midterm. Those Canvas quizzes are 12% of your grade. Problem sets, I'll describe these more in detail in a second, 24%. So you can kind of see these problem sets are going to be something that are almost the same weight as an exam. So these would be something that you want to expect to put a lot of time and effort into. And this is really going to be, I think, the real value in this class in terms of what makes you more attractive to companies and organizations in terms of a worker, right? This is where you're going to really build the skill of learning how to work with data. So all of you to get in this class have taken some level of statistics, right? This is really, I think it's, I think it's an introduction to econometrics. Really, I will go through some of the theory, right? We're going to work through some of the theory. I'll hand wave over some of it in terms of the mathematics. What we're really going to focus on in this class is the application of statistics, right? So that's kind of what the problem sets are meant to really test. We'll then kind of have in-class quizzes. This is just a way for me to incentivize, right? We're econ majors, a lot of us. How do I increase people's ability? I have to increase the marginal benefit or the marginal utility. Tying points to class attendance, right, is one way for me to do that, right? And so we'll use some in-class quizzes. I'll explain how those work here in a second. Pretty small percent of your grade. These cords must not be working very well because I keep losing my screen. So this might be a problem throughout today's class. Well, I can kind of operate it off of here until we see if I can get this to work again. All right. So I don't have a screen in front of me right now. Hopefully I can get this sorted out with the tech people. But what will these class participation quizzes look like or in-class quizzes look like? So you don't have to come to class necessarily, but if you want these points, you're going to have to be here. Okay. So I'm going to use kind of these in-class quizzes randomly throughout the semester. All right. So we'll have a total of kind of 12 quizzes, and they're going to account for what do I have this to be? Each one's worth 4 points. Multiply that by kind of 12. And that's kind of how you. Oh, this is annoying me because it's really going to be a pain for me to have to keep turning back. See if we can get this to work. It's timing out on me for some reason. It shouldn't be. Okay, well, maybe I won't get it to turn on. We'll see if that fixes it. So there we go. So we'll have 12 of these throughout the semester. They could be on Tuesdays, they could be on Thursdays, right? I won't kind of announce it ahead of time. They're going to be kind of random. At the end of the semester, we'll have 12 total. I'm going to take your best 10, right? So if you miss a class here and there, that's kind of building in these two lowest. It's almost like sick days. So if you miss one, instead of me having to vet every single person's excuse or reason for why they missed, those are like your built-in sick days, right? So your grade on Canvas, you can think of almost like as a worst case scenario if you keep missing class at the same rate, because it's not going to drop those until the very end of the semester, okay? Excuse me. So what I'll do with those Canvas quizzes is, and this is where it's going to be tricky for me to show this to you, so I'm kind of annoyed with this computer. So I'll have something like this. Here I've got a background survey, so don't start filling this out quite yet. But if I was using this as an in-class quiz, which I won't start with those until next week, since people are still kind of shuffling their schedules from this first week, is I'll kind of publish it, right, under whatever module we're in. So you can then click on it on Canvas. Now, I think if anyone's working along with me, is it asking you for a number? Does anyone want to try this out for me? Yes, no? So I published this, should be under kind of that module 1. Is anyone getting that to open? No? Yeah? Did it ask you for a number? No.
It's asking what is your highest level of math?
Okay, so this one I didn't tie a number to. So usually what it'll look like if we're using these in class is I'll give you a number and say today's number to unlock the quiz is 18.35, right? So you won't know that unless you're in class. So that's way for me to make sure you're not just sitting in your dorm refreshing until I open it up during class and then you answer the questions, right? So a lot of the times these will be pretty easy. So this is more of a background survey. I just want you to do this by the end of the day Sunday. This just gives me a little bit more information about you as a class, kind of what your interests are and how I might start to change the class accordingly. I've got tons of different data sets laying around that we can look at. And so I try to kind of get an idea or a pulse of what the class looks like. So usually I'll give you that number, but that's what I'll do. I'll kind of deploy it. You won't see the quiz ahead of time. I'll deploy it in class and then give you the number that lets you in, okay? So here we'll go to, oops, there we go. So that's what those in-class quizzes will look like. You're graded for correctness, but a lot of the times we work on these together. Sometimes I'll give you 5 to 10 minutes, right? And have the due date set to be 5 to 10 minutes from when I publish it. I'll then kind of let you work with those around you. But a lot of the times we'll talk through them. So if you're paying any ounce of attention in class, you should be able to get the majority of these points on these in-class quizzes, right? So it's only a small percent, like 4% of your overall grade. But if you end up near a cutoff, right, making sure you're in most classes is going to be enough to kind of bump you from B to a B plus to A minus, et cetera. Okay. So class attendance is highly encouraged, and that's why I'm tying points to it. So these problem sets, we'll have one roughly every 2 weeks. It kind of depends on how we're covering material. Usually I have them due at the end of the day on Thursday. Once again, this will depend a little bit in terms of how we move. I like to make this class organic where I don't have hard and fast due dates set ahead of time. But generally, once I assign them, let's see, do I have here? Oh, I don't think I put it up here. But usually once I assign it, you'll have at a minimum of 1.5 to 2 weeks to work on it. Okay. Sometimes I'll get them up early. You might know might have covered all the material, but you can at least get started like on the first half. So by the time that I actually have covered all the material, you'll have at least another week to complete the assignment. But it'll usually be up there on Canvas for at the very minimum 2 weeks, right? So we're gonna have 6 of these throughout the semester. I don't drop any of the lowest. Each one kind of has the same weighting. So each one is worth 3%, right? We've got 6 of them. No, hold on. That's not, this should be 4, right? Sorry. They're each worth 4% of your overall grade. So we have 6 of them, right? That's what gives us a 24, right? So I was kind of updating things here a little bit, and I forgot to update this slide. I'll get this edited after class. So we'll walk through how you actually access the program to complete these problem sets here in just a second. But that's how many we'll have. I've got some important dates. So this is the final date. It's kind of similar to class, but a little bit, varies just a little bit differently. I don't choose this time. The university gives it to me. So make sure you're looking at this date, and then that midterm is going to be our usual in-class time. Make sure you have no conflicts with that well ahead of time, right? And if you do, let me know. If you let me know things well in advance, it's a lot easier for me to make adjustments, right? So that's kind of the general expectations for the class. So how do you succeed, right? If I'm summarizing everything I just said, right? Show up to class, right? If you want to read the chapter, or at least I say the chapter, probably more likely, glance over the slides before we meet in class, right? I'm always putting them up that Thursday of the class prior to the next week when we cover it. So take a glance at the slides. Just kind of helps with like getting some terminology. Even if you don't understand exactly what's on there, it gives you some idea of what we're going to talk about. It makes class time a little bit more effective, right? So looking at things in advance, doing these practice questions I give you. So leading up into the quizzes, I'll give you sets of practice problems for those quizzes that you should be able to review. And I'll give you the answer key as well. So you can kind of look at them, know the types of questions you're going to be seeing on the upcoming quiz. Excuse me, those will help you. They're also good to be able to go back to and review once we get closer to those exams. I'll always give you a practice exam before the exam. Those are going to give them to you for a reason. They're going to look similar to the exam and are going to be really helpful if you actually work through them. Okay. Take those Canvas quizzes seriously. So when you're opening those, I'm not policing them, right? They're meant to be lower stakes in the exams. You have access to your notes, you have access to the slides, you have access to everything. Have all those resources in front of you when you sit down to take that quiz. Okay. Don't think I mentioned. No, I'm forgetting. Where is it at? There we go. So I didn't put this up there, but once you start those quizzes, you'll have 60 minutes to complete them. Right. So this is in the actual syllabus. I forgot to add a bullet point here, but you'll have 60 minutes to complete those quizzes once you start them. You can't pause and restart. So make sure when you're sitting down to take those bi-weekly quizzes, you're ready for the next 60 minutes to answer all of the questions, right? They're usually between 10 and 12 questions, so they're not really long. So if you average that out, about 5 minutes-ish a question. Usually it's going to be less theoretical and me giving you output from this program. We're going to be using Stata, and then you kind of having to do some work with it. Once again, this will be a little bit more apparent what this will look like as we work through those, as we start to get practice problems out there, and as we start to actually use the program itself. Okay. So, right. Don't miss assignments, right? I can't stress this enough. This is statistics, so hopefully we start to understand this relatively early. But zeros will pull your average score down very quickly, right? Even if you give it a half-ass attempt and get 50%, that's not going to impact your grade near as much as a 0, right? So try to make sure you're turning things on time. I don't accept any late work, late problem sets, late quizzes, late in-class quizzes, all count as zeros, right? Zeros will kill your grade. All right, so make sure you're at least, even if you don't have enough time to do a really good job, even on these problem sets, submit something, right? Some points are better than none, okay? Don't be afraid to ask questions, right? This is all going to be new to all of us, right? I mean, has anyone used Stata here before? I probably didn't think so. Usually, sometimes I get 1 or 2. It's going to be new to everyone, right? And so I'm going to try to start out slow. It's definitely going to be something that has kind of a steep learning curve. Once we get into it, it becomes a little bit easier, but these first few weeks will be tough, okay? So my office hours at this point, I have a GA. Their office hours should be in the syllabus, right? So they'll have office hours every single week. I've got my office hours, which are Monday and Wednesdays in the morning. If, it's a big campus, I don't know where all of you live. It's kind of a hike sometimes to get to my office over in Wiley, which is up the hill, whichever direction I'm kind of turned around. Yeah, so that way, right? I'm up on the third floor. If you don't want to come there in person, I always start my office hours. I open a virtual link, and then basically as people kind of join, I can admit them, and I just kind of take them, first come, first serve. I will let you know you are going to be competing with 600 B251 students for my time, which, especially around their exam dates, office hours become busy. They're also freshmen, and I typically see fewer of them at 9:30 in the morning. So maybe the earlier office hours might be a little bit less traffic. Also, if these don't work for you in any week, you do want, a 15, 30-minute meeting, feel free to email me. I like it, I usually here, I have other commitments, but I'm usually in my office or at least somewhere in the building 7:30 to about 4 every single day, right? So I can, schedule something if these office hours don't work for you. But I can guarantee I'll be available during this time every single week. Okay. Any questions on anything up to this point? Should be okay. All right. So get through here. I don't think there's anything else I want to ask at this class or at this point. So we'll kind of start jumping into just some basic review of statistics, things you probably learned in 370 or the equivalent that you took. And I'll try to save some time at the end to make sure we get a little bit of experience of how to download and how to use this program's data, okay? So really, one of the main things that we're going to be doing this entire semester, if I had to summarize it into one sentence, is we're going to be trying to understand the causal relationship between one variable and another. At its core, that's what we're doing the entire semester, right? Now, we'll talk about how do we make sure we're not just getting a correlation, right, and moving to an actual causal relationship. So examples would be like, does the class size of a course impact student test performance? So we're worried about this in B251 all the time, right? There's sections of 300, and then there's ones led by TAs that are 30, right? Does that actually impact student performance? Okay. Maybe I want to know, does an individual's, and now my screen is somehow back. Now we might want to know, does the race of an individual impact the kind of APR percent that are given on a mortgage, right? We can identify discrimination, right, through a lot of what we're doing this semester. I had, how do taxes actually influence consumer behavior, right? We think that from our basic econ courses, if you increase taxes, it increases the price and people do less of it. What we actually see is for certain goods that are fairly inelastic, maybe we don't actually see that much of a change in consumption. So instead of just basing it off our theory, we can use data to actually see if that theory is supported, right? What do people actually do? It's great to have all the theory in the world, but we live in a world now where we can get data on like everything, right? So we can actually test these theories and then say, oh, they're not right. We need to update them, okay? And then you can do like predictions using historical data. So you could do this like, trying to predict future stock prices. I've occasionally messed around with, and I don't have a great money-making scheme yet, but I've been playing around because there's so much data on all these online betting things that you can scrape the data and actually find out where the general public is making mistakes, and then using that historical data, figure out what bets are actually not set correctly and make them right. It's basically the same thing as buying and selling stocks, right? If you can identify where other people are making mistakes, you have an arbitrage opportunity to actually, make some money. So we can do a lot of cool things. Different data sets we'll be looking at are basically 3 different types. So the majority of what we'll do in this class, we're going to start out with is what we call cross-sectional data. So this is going to be, we have many, many different subjects, right? But we have it at one point in time, right? So this might be, I have every single Econ 371 student, but only for the current semester, right? Many subjects, but at one point in time, okay? Time series with data would be if I had one of my students and I had what their average GPA was in every single semester. One subject, multiple points in time. So cross-sectional, multiple subjects, one point in time. Time series, one subject, multiple points in time. By the end of the semester, really the second half, we're going to be dealing a lot more with panel data sets, which is I have multiple subjects, maybe every single person in this classroom, so many, many subjects, and I have what your GPA was for all of you in every single semester you're here. So many subjects, many points in time. Kind of mashing cross-sectional and time series data together gives us these nice panel data sets. And really just more data, we can answer more questions. Okay. So I think I had some examples here that are different than what I just gave, but like maybe I have a bunch of different cities and what their population was in the 2020 census, right? Many subjects, but at one point in time. Right? Another example of cross-sectional data, maybe I don't just have one variable, right? Cross-sectional data, I can still have many subjects. So here I have many countries, but I can have multiple variables. So they're all collected at one point in time. So in this example, this was all from 2011, but I have multiple variables, right? For every one of these countries, I have their GDP per capita, primary and secondary education expenditures, right? So we don't just have to have one variable in these cross-sectional data sets. We can still have multiple variables. It's just they're all recorded at one point in time. Okay? Here's kind of an example of what a time series data set would look like. I have one subject, the US, I think. Yeah. I've got many, many different years, and I have the unemployment rate in each one of those years. So one subject, multiple points in time. Cross-sectional data, I'm mashing those two together. So I think that you guys are aging out of this. I wish I had newer data. At one point, I requested ISTEP data. So let's think, 2009, 15 years. I think the lowest grade I have is 5. So you guys are too young now. But if you were in Indiana and you took did you guys have to take the ISTEP? Yeah. So if you took the ISTEP in 2009, 10, or 11, I have data on you, right? I don't have the actual name. I just have your identification number through the state, but you can go out and request this type of data where I've got the same student. So student ID 1, I have their ISTEP score in 3 different time periods, and I have that for multiple students. So that would be an example of a panel data set. Okay. So you can kind of hopefully see, like, we're getting things here that look like a little more macro level, right? We can look at country level data. We can look at individual level data. We could even look at company level data, right? We're going to be looking at a lot of different data sets throughout the semester, and I try to vary them, like what we're looking at, because I know everybody has different interests, and that's where that survey kind of helps me bring more things into class that I know that more of you are going to be interested in. I think one semester I had this was before I was at IU. I previously taught at Ball State, and they have it's like a marketing thing, but it's for like specific to like clothing or something. And I had like 4 students who had that major, and they were all interested in like high quality clothing data. I found a data set that worked for the class that we could look at, right? So try to think of things that really do interest you, and I'll try to see what data I can find. Just if you're interested, what I will probably use, it's called, I don't know how to say it, Kaggle, Kaggle, but they've got all kinds of free data that you can download. So when we're talking about these data sets, right, we're going to start to use some notation, right? So we can have population data sets or we can have sample data sets. So population data, as a general rule of thumb, we're going to use either capital letters or we're going to use, do you remember from the other stats courses, typically use Greek letters, right? So population data, we'll say the number of observation in the population is capital N, right? So this could be every single US citizen, every single country in the world, every single Indiana school, kind of depending on what my question actually is, right? Now, our sample data, see if I skip here. Do I have it? No. So we're going to talk about sample data later. But my sample data would basically be I'm randomly taking a certain number of subjects from that population. So for my sample data, instead of a capital N, the total number of observations in sample data we would represent with a lowercase n, right? So we're going to choose someone at random from the population. We're then going to record what their outcome was for a specific variable. So maybe I'm interested in this classroom, what your, I don't know, well, doesn't really necessarily apply to you as much, but maybe I'm interested in your credit score, right? So I randomly select one of you. I know credit scores have to be within a certain range, but when I randomly select one person from that population, everyone in this class, I then would record what their credit score is, and I would kind of do that. If I wanted 10 people in my sample, I would randomly select 10 people, have the recorded credit score. That's my new sample data set. Okay. So we're going to think about when I'm randomly selecting these people, or when I'm randomly selecting, it could be firms from the population. Each one, I want to record a variable y on, and I don't know the outcome ahead of time, right? I know it, I might know the range, but I don't know what the actual value is until I actually select that person. And my screen just went away again. So this is going to be an interesting conversation with the tech people. So what we can think about is, I know that, for instance, if I was going to select one of you from this room and I'm interested in recording instead of your age, well, I know that you could potentially be like 24, right? You could have started at a community college, transferred to IU. You might have been here a little bit longer. You could be a little bit older than the average or the typical college student. But I know that most of you are probably juniors and seniors. If you have a traditional path, you're probably, what, 21, 22, right? So I know that certain values, if I selected one of you at random, are going to be more likely, right? But it still could be that you came in with a lot of credits from high school. You could be technically a freshman in this course, right? You could be 18. Probably now at the fall, probably 19, but still. So I know that there's different values I could see, but I know that some of them are going to be more likely than others, right? So we're going to start to think about, if I select a variable at random, it could take on a bunch of different values. So say this variable y that I'm interested in recording, it could be equal to 10. Or in my case, in my example, it could be equal to 21. I know that that probability of seeing the age value be 21 is likely higher than the probability of seeing it be equal to 24 or 19, right? But every single value has an associated probability with it. Maybe some of them are zero. Like, what's the probability I selected one of you at random and you're 9? Probably zero, right? I mean, I guess there's probably a 9-year-old it has been a 9-year-old, maybe an IU at some point that's taken this course, but I doubt it, right? And so even if I have values that don't make sense, they still would have a probability associated with them. It's just that probability would be zero. Okay. So I can kind of think about, if I had an example, and this I went back to the iStep data. If I randomly select these students, I start to see that scores here are a little bit more likely. I can represent this with, essentially, what's the probability I see? I don't know. This would be about what, 348, right? What's the probability I see their iStep score be 320 or close to it? A lot lower, right? So we can kind of depict these probabilities in what we call a distribution, right? This essentially is showing us that I'm randomly selecting someone from my population, but I know that certain values are going to be more likely for them to have for that variable than other values, right? If I try to kind of map out like the top of each one of these, I would kind of have what looks more like a smooth distribution. That won't always be the case. Some variables we look at, they're going to be discrete. All right, so if I look at like age and recording ages in years, I'm not going to have like every single day by day age. It's going to be a little bit more, discrete as opposed to continuous. But we still have a distribution for that variable. Okay. Here's something if it was a little bit smoother and I broke this iStep data down by, like, let's say instead of just measuring it to the integer, I could measure it out to whatever decimal I wanted. I might end up with a really nice kind of smooth distribution. Okay. And what's that showing me? Where are the majority of the observations? If this y-axis represents the probability that if I select one of these kind of students at random, that the score of 360, the probability is right here, what is this distribution telling me? That most of the scores in the data set are around what values? 360 or high 350s, right? And then it's telling me that values further from that, or what would this approximately be? The mean, right? Kind of that highest point of my data set here. I try to choose something that kind of looks nice and symmetric, right? That peak of my distribution, if it looks like it's a pretty symmetric, should be my mean, right? And then as I move further from that mean, it's less likely I see values further away from that, okay? So that's all these probability distributions are telling us, okay? You probably in your other stats courses talked about very specific distributions like the standard normal or the student t. We'll end up talking about those as well, but for now, we're just thinking about these kind of probability distributions, okay? Where are we at in time? Okay. So just some notation that we'll use. And once again, I won't focus as much on the nuts and bolts of the theory. I'll do some hand waving throughout the semester, but you'll often see me notate or kind of show you a formula. And if I'm ever using this summation sign, right, this capital sigma, this is how we would kind of read it. Starting at the very first observation in my sample or population data, going all the way to, in this case, just the fit. I'm going to take every single value and add it up. Well, here, the value is just 2. So what this is telling me is take the value of 2 and add it 5 times, right? So 2 plus 2 plus 2 plus 2 plus 2, which would give me the value of 10. Right? Now, we're not often going to be summing just one single value. What we're going to be doing is looking at, okay, I've got a data set. Maybe it's everybody in this classroom, and I want to know what's the average GPA of everybody in this classroom. So I'm going to start randomly selecting. If I have population data, that means I have every single person in this room. So I'm going to start with the first person. I'm going to take their value for this variable y I'm interested in. So I'll take the first person's GPA. I'll then go to I equals 2, the second person's recorded GPA, add to that the third, the fourth, the fifth, etc., until I have every single person in this classroom. And if I want the mean, once I add up everyone's GPA, what do I need to do? Divide by the number of people, right? So this is how we're going to use this summation sign. It'll show up in things like the calculation of our mean and our variance, okay? So just some kind of measures that we would have that measure kind of the central tendency of our data set. So I mentioned in the previous distribution, it looked like that mean was just under 360. How do we actually calculate the mean? We're going to go through our data set, add up every single person's value for this y variable, and then divide by the number of people in our population or the number of people in our data set. Now, what is the mean heavily, and we could do this for expected values as well. I'll kind of hold off on this. If I had like grouped data and not individual data, we would do a similar thing, but we would have to use probabilities. So we'll kind of save this for later on, but we can find the mean of not just individual level data. We can find means of group data as well. In fact, next week I have an Excel file which we'll kind of look at that does this, okay? Now, what is the mean going to be greatly influenced by? So let's say I'm calculating the average income of, say, 20 people. And one of those people that I selected accidentally was Elon Musk. What's going to happen to my mean? It's going to be really, really high, right? Because he's an extremely high outlier, right? So our mean is going to be greatly influenced by extremely large, but also extremely small values, okay? So if we have small data sets, we're concerned about this, right? If we've got millions of people and we end up with Elon Musk, it doesn't influence the mean near as much, right? But if I only have 20 people in my data set, that one extreme observation could really influence the mean. So another measure that we have when dealing especially with small data sets is this median. So the median is that if I had 20 people in my data set, I would arrange them from smallest to largest, and then cross off the lowest, cross off the highest. Cross off the next lowest, the next highest. Every single person would kind of only count once until I get to those middle two values, and I would then take kind of the mean or the average of those two. So what that does is when I have Elon Musk in my data set, his value got crossed off right away. He wouldn't have near as great of an influence on my median as he would on the mean. So we have the mean and the median are kind of measures of the central tendency of the data. And then does anyone remember, I've got it here, but how would you calculate the mode? It's just the value that happens the most, say it most simply, right? So we've got 3 measures of central tendency. We can get all of these from Stata. We can calculate all these by hand. We'll kind of get more practice in this as we work on things next class. But I just wanted to kind of mention them here, doing some basic review. Let me see here. How far do I want to go? Oh, okay. Are we on time? I think we can get through this pretty quickly. So here's our measures of central tendency. The next thing that we'll want to look at is when we look at distributions, right? Some of them look wider or more narrow, okay? So when I'm thinking about what that's telling me, what's the variation or the variance in my data set? So what we're going to do, once again, we have this summation sign. We start with the first observation. We look at that observation's value for that y variable we're interested in. So if I do my income example, I would look at the first person I selected, their income. I would look at the difference between their income and my mean. So we would kind of call what's in parentheses here the deviation of that person's income from the mean, or the deviation from the mean. I would then take that person's deviation from the mean and I would square it. I would then go to the next person, take the value that they had for their income. It's deviation from the mean, square it. Do that for every single observation and add them all up. Once I do that, I would then divide by the total number of observations I have. So what's maybe one way I could describe the variance? When I was looking at the mean, I added up the value of the variable for everyone and divided by the number of observations. And it kind of told me like what the average income of this data set was. What would the variance be? It would be the average. Well, what's in my numerator now? Not just the value of y, but y's deviation squared. So the variance is almost like the average deviation from the mean squared. Right? That's another way of interpreting it. Now, why do we square that deviation? Well, one, it's nice because do we care if that observation is above or below the mean? No, we just care how far away it is. So if it's above the mean, that deviation would be positive. If it's below the mean, that deviation is going to be negative. If we simply add those up, the positive and negatives cancel each other out. We could end up with a variance of 0, but we know there's variation in the data. So when we square it, you might think, well, you should just take the absolute value, do the same thing, right? When we square it, it makes everything positive. Positive times a positive is positive, negative times a negative is positive. So that's one contribution squaring it. It doesn't care what side of the mean we're on, we're looking at that deviation. We don't care if we're 5 below or 5 above. Now, the other thing that squaring does is if I take the value of 2, so let's say the deviation from the mean is 2 and I square it, that becomes what? 2 squared is 4. But if the deviation instead was 3, well, the difference between 2 and 3 is just 1, right? When I square those values, 2 squared becomes 4, 3 squared becomes 9. What's the difference in those values? 5, right? So it over penalizes us for having observations that are really far away from the mean, right? So the variance kind of does this nice thing where it doesn't care what side of the mean that the observation is on, but it also over penalizes really extreme values, okay? So you could imagine, like, let's say, just to kind of make this point, all right? So let's say I had, I don't know, 1, 1, 1, 1, and we'll do 3 here, right? So if I were to kind of look at the variance for this data set, I would calculate this average, right? And if I had a very similar data set, but this was like, I don't know, 100, right? If I look at something like the median, right? Or if this was a larger data set with a bunch of 1s and a 3 and a bunch of 1s and 100, maybe the means end up being pretty similar. But the fact that this one observation is really extreme, this data set has much more variation. Now, it's still only one observation that varies, right? Every other observation is equal to 1, but we want to somehow capture with the variance that, yes, it's only one observation that is different, but in this data set, that one observation is really different, right? So by squaring it, we're going to over penalize these really different values or these extremely high, or I could give you an example where I had like an extremely low value as well, okay? So the variance will capture both of those for us. We're then going to use a scaled version of the variance, all right? And once again, we'll come back to this discrete stuff where we're dealing with probabilities kind of in the next week. I'll revisit these slides just for the sake of today. Gives us a little bit more time to talk about stata. We'll also use a scaled version of the variance, which is once we calculate the variance, we'll take the square root and we call that the standard deviation, right? That'll have a lot more uses for us later on when we start to talk about things like confidence intervals and hypothesis testing. But it's basically just scaling that variance. We're taking the square root, okay? Now I've written everything up here in terms of the population. So this is where I said we use Greek lettering. So the variance is sigma squared, standard deviation is sigma. This is for population data, right? We're looking at sample data. I'll start to write the variance as, do we remember from other stats courses? It's not sigma squared. If it was sample data, it would simply be S squared, right? We go from Greek lettering to kind of our typical English alphanumeric lettering, lettering. So we'll look at some of this next class. I want to kind of move on a little bit just so we make sure we have time to kind of go through stata today. So we'll pick up on some of this stuff next class. I want to make sure that we have time to go through. We'll skip ahead. Did I already skip through it? Yes. Oh, there we go. Right? Introduction to stata. Okay. So this is where I would write this down. This will be in the recording, so it'll be useful to go back to. Um, but I'm going to walk you through the steps of how you download Stata and how we start to use this program. Okay. So before I start to describe things, everything that you should be using as I'm kind of walking through this are your IU credentials. Don't use Gmail accounts or anything like that. Use your IU email address. Okay. So what we're going to do here is first, we'll eventually need these files. So I put them up on the homepage, but anything I put up on the homepage, I also put under the files tab. So like here's week one. Every week I'll kind of put, I've got the slides and other files, but I also try to create subfolders where I put just the files you'll need for the Stata work that we do, right? And once again, it's Stata, data, depends on who you ask, right? But I might go back and forth between both of them. I never know what I think I looked it up once and you can really say either way, right? It's like I said, data, data. So here I've got an Excel file. I've got a CSV file. And here is something that's a do file. This will eventually start using in Stata. But all of these you can download. And what you'll want to do is download these not to your own device. I mean, you might have to download them to your device first, but you then want to move them to your OneDrive. Okay. So if you aren't real familiar, you don't use your OneDrive a lot, right? We'll go here. I can see my mouse. There we go. Go to one.iu. We'll go here in the search bar. The first thing we're going to do is search for cloud storage. We're going to click that cloud storage. So here I'm not logged in. So I'll try to remember the things I already have set in my account, undo them and redo them for you, right? So right now I'm not logged in, so I'm going to log in here. I've got my IU username, so this will be the first part of your IU email address. Then your password for whatever your IU account is. You're then going to log in. Taking a little bit of time here. So now that I'm on this cloud storage, how many of you already have a check mark next to that IU if you're working along with me? So this step you can kind of ignore, right? Your OneDrive from other courses or whatever you've done is already authorized. If it's not, and this is where you don't look at your personal OneDrive, you want that IU OneDrive, okay? Mine is currently authorized. If it wasn't, it would look like this, okay? It would give me the option to authorize this. So I would click authorize. It might send me back through. Annoyingly, I have to re-sign in. See if I can type things correctly the first time. All right, there we go. I'm going to have to go to continue. I've got my two-factor authentication if I can find Duo on my phone. Oh, there we go. Now I've got my IU OneDrive authorized. Okay. So once I have that stage set up, I'm going to go again back to OneDrive. Okay. Instead of cloud storage, I'm going to go to IU Anywhere. Okay. So IU Anywhere, how many of you use this for other classes? Yeah, so it's a way that like the university pays for a license for a program that all students can use, as opposed to like if you weren't an IU student, you have to go out and buy Stata. It's expensive. I forget how much it is, but it's pretty pricey to get an individual license. So we're going to be operating off of like a shared license that the university bought. Okay, so we're going to look at IU Anywhere. Should be the first thing that pops up right here. And once again, if you have any questions, feel free to stop me. I might not be able to troubleshoot everyone's questions in class. Everyone's got slightly different devices, Macs versus kind of typical Windows operating systems. But outside of class, if you're having any issues at any point, I can kind of try to help you troubleshoot. And if I can't figure it out, we'll reach out to the tech people. I haven't had a semester yet where we couldn't get something resolved fairly quickly. Okay. So the next kind of step is going to be, I'm going to end up with this Citrix workspace. Okay. So usually it'll ask me to detect it, or I think if you haven't used it before, or is asking you any of you to sign in, or are most of you seeing this? And you select IU Anywhere, and then you're seeing that? Okay. There is an occasion where if we go through these steps and it doesn't work, go back to this step that would get you to this screen, like go back and, authorize it, go to IU Anywhere. Sometimes using the light version will help. We want to avoid it if possible, but that can be one of the first troubleshooting things that we'll look at. But here, let's try to detect. I'm going to agree here. I'm going to download this Citrix license. Now, this should be something you only have to do once on your own device, right? I have to do this every single time I sign into this computer because it like wipes it every single night. That might be a lie. It might wipe it every week, but still I have to do it every so often. So it'll then kind of run this. You can kind of see that it popped up that download, right? I'll then hit continue. Now here I've got this download, this Citrix Workspace app. I'm going to click on it. I can get it to go here. Got the spinning wheel here, so we'll see how quickly this pulls up. Oh, you've got to be kidding me. This program, this. We'll see if this gets it, hopefully. Okay. Hopefully have enough space in this computer. I just tested it the other day. If it gets stuck on this point after you've kind of opened it, so you can hit continue here, hit agree, hit install. Kind of wait here. It takes a little bit of time. I shouldn't have to go through all these steps every single time. It's because I deauthorize it to kind of show you how to authorize it here. So we'll wait for a second. Hopefully we can get it downloaded relatively quickly. It's chugging along. Is it hopefully going quicker on some of your devices? Hopefully if you're following along with me. All right. So we get to this point. Okay. So I'm going to just exit out of this. I'm going to go back to here where I had it open on the web page. Once it's downloaded like that, I can put it's already installed, and then I can use it from the web browser. For me, this is a lot easier. So once you have that downloaded and it kind of gives you that prompt, you can go back to the web page, hit it's now already installed. It now gives us what hopefully once you get it download on your device. Now when you go to IU Anywhere, now it should automatically pull open the screen. Right. So once you get Citrix downloaded, now when you go to IU Anywhere through 1.IU, you'll always see this. Now, I've added a favorite, right? But generally, when you first start out, you'll have to go to Apps, scroll down here. You should see Stata Now 19 SE. If you click the favorite button, hopefully maybe some of you, this seems like really rudimentary, but it shows it then on your homepage, so you don't have to go through these steps and sort every single time. So you can do it from either the apps or once you set it as a favorite, do it from your homepage. I'm going to go to open this program. Looks like it wants me to download something else. So sometimes I think it'll pop up with this ICA. So I'll click on that and give it some time. Oh, no, there it goes. So then it'll start running kind of down here in the bottom right-hand corner. This can sometimes take a little bit of time. Once again, it might be helpful to try to get things up and going and get the program opened up before we start class. Once you get here a couple minutes early, just so that once we get to this point, to a point in the class where we're using Stata, you already have the program opened up. You don't have to wait for it to kind of load because this is Valentine and like there's a lot of students. Sometimes the Wi-Fi kind of gives us some headaches, right? So try to get this kind of opened up prior to class because we're going to use Stata in most classes. So once I go through these, now I've got the program. It looks just like any other program that's opened up. Okay. So those will be the steps that you use to kind of download, right? Kind of be able to access this program through this shared license that IU has. Okay. Did anybody walk through those steps, able to get it pulled open at this point? Yes, no, yes, a couple people. Okay. Like I said, if you're having issues with this, I can kind of try to help you, even if we get out a little bit early here today, or send me an email. Office hours will be a good time. Let's try to get this resolved in the first week. So make sure you can get to this step by the end of this week. And then if you can't, reach out to me and I can kind of help you. Okay. So just a couple basics about Stata before we kind of end today. So we can open up different data files. So once we get later on in the semester, I'm primarily only going to be giving you files that are actually in the format that Stata can open, right? So I'll show you kind of what I would generally do if I would just open this program up. So there's going to be three things that we want. So we've got the actual program. There's this little notepad up here, right? So I'm going to click on this. This opens up. This is where it's going to be a little bit more problematic that I can't see the screen. Oh, there we go. So it opens up a different window, right? So here's the program. Once I clicked on that little notepad, it opens up what's called the do file editor, right? So we can start to type commands into Stata, but it doesn't save any of that, right? So anytime I want to save my work, I'm going to type it into this do file and then save it here. So for instance, and we'll talk a little more about these commands, but I can create a variable. So I'm going to call this generate variable 1, right? Set it equal to the value of 5. This will not be an interesting variable. It's just going to set the value equal to 5, right? So if I kind of click, if I have this kind of line of code, it's not really actually going to do anything. So I can copy this, put it in my command bar, right? And then go here. Okay, it didn't really create anything because I haven't opened up a data set yet. So that's not really going to do much. The first thing that we actually have to do, so I've got my program, I've got my do file. I'm actually going to have to open up a data set. Okay. So the way you'll do this, and you can do this all from the interface, so it's very user-friendly, but anytime I do something from the interface, it'll tell me the code that also does that. So first thing we'll do is I'm going to go to File, I'm going to go to Open, and I've got some files here that are already in stated dataset form, right? So I haven't given you any of these yet, so we'll kind of talk about how we open Excel files here in just a second. But if I already have a file that I give you that ends with a .dta, that means it's already a data set Stata can just open up. So you go to File, Open, I click on one of those data sets. Okay, I'm going to drop the old data because I'm opening up a new data set. Notice it gives me the code that actually did that. Okay, so it kind of runs over here on the, probably should make this a little bit smaller so that in the future it doesn't. But what I usually do is if I want to do something from the interface, I now have opened up a data set. So I've got the program, I've got my do file, and you typically want to have a third window as well, which is if I go up here, see there's this little like grid with a magnifying glass and a grid with a pencil. Don't open the grid with a pencil. That allows you to edit the data. Typically, there's almost no case where you want to manually edit the data. The data should be what it is, right? You don't want to fabricate the data. So if we just want to look at the data set we opened up, we're going to go to this one that has a little magnifying glass. It now opens a separate window. So we now have the program, the data set, and we also have, whoops, our do file. Those are the three windows that we want to have opened up. The do file was using the notepad. The kind of data we use, that little magnifying glass. So the data that I just opened up was some COVID data. So I had like the number of cases in 2 different months. I had the county name, state, number of new cases, what region it was, a bunch of different variables, right? So this is the data set that I have opened up, okay? Now, if instead of using this interface, which to start out with, it's probably going to be easier to like file open these programs. But once I close out of this program, all of this goes away. There's no way for me to save this. But what I can do is I can highlight this command, which is what opened up the data set. I did it in a much more user-friendly way, but I can copy that, go over to my do file, paste it. Now I have to get rid of this because it was on separate lines. This is kind of a goofy computer the way it's displayed. So if I run this same line of code, I can highlight it and go up here to this little play button. What that will do is it reuses that code and sure enough, reopen that data set for me. So I can do things from the interface and then it spits out what the code that actually opened the data so that I can then copy and paste that into my do file. And then my do file is what I can save as, whatever I want to call it and save it to my OneDrive. Okay. Now I should make a point here. The whole reason why we went through cloud storage first and everything is because the only files I can open up cannot be from my desktop. I can only open files that are on my OneDrive. So you need to create a folder on your OneDrive that is like ECON 371. And then every single week, I would probably create subfolders just to make it easier. But every single week, you'll need to go to those files that we have on Canvas and download these. Maybe they'll originally download your device, and then you need to drag and drop them onto your OneDrive, whatever folder you created to put the data files for this course in. Okay. Is that any questions on that idea before we keep moving? Okay. So every time we're looking at stuff, instead of every week or maybe bi-weekly, kind of depending on how quickly we move through material, I'll give you a do file that I've already saved. Okay. So when we go back to Stata, so we've got the program opened up. I'm then going to go to my do file editor. Whoops. I don't want to save it anymore. If I go to my do file editor and go to File, Open, one of the files that I had on Canvas that you should have dragged and dropped on your OneDrive. So I've got my folders. I think I had it in week 1. Was this review of statistics file. So this was a do file I created ahead of time, and I'm giving to you before we go through things in class. Right? So you'll go to that do file, you'll open it up, and look at all of this code that we get to start to talk about. Right? So this may look daunting at first. We will kind of walk slowly through this on Thursday, also parts of next week. So this is really, this do file is going to be week 1 and week 2. Okay. So I showed you how to open files already. If we don't have Stata files, so most of the data, if you go to look for things online, is going to be like an Excel file or a CSV file. So we can also open those up. So instead of file open, the data sets I gave you for this first week was a CSV and an Excel file. So the CSV file, I go to, instead of file open, my screen keeps going away, I go down here to import, right? It's a CSV file, so I'm going to click that. Excuse me. Then I'm going to pop up this window. I go to this little folder tab. Okay, I go to my OneDrive. I'm already selected in the ECON 371, my week 1 materials. I've got my state cigarette tax. This was one of the files I gave you on Canvas. So once you drag this into wherever you want to open it up on OneDrive, you can then open this up. It shows you what the data is going to look like. We then hit, this is where I think, oh, why can't I see where this is at? Should be just an OK button. There we go. So I then hit OK. This is a little bit goofy because of the way that it's displaying. We'll hit OK. Do you want to replace the old data set? Yeah, we want to open up this new data set. So it tells me the code that actually did that. So I can do it all from the interface. This code would actually reopen that data set up for me. So what I did was I copied this code, and then in that do file I gave you, that's what this first line of code does. So instead of going through all these steps to open the data set, when I give you that do file, you could simply highlight this, click that little execute button. It'll just run this line of code, and it opens up that data set for me. Okay. So a lot of times I'm going to give this code you ahead of time, so you don't have to like go through file import. You're already going to have the code in that do file that I give you. Okay. So we can do that with CSV files. It's going to be a very, very similar thing. If I go back to the program, I can also import not only CSV files, but Excel spreadsheets, right? So I think the other file I gave you, go to browse here, that I dragged onto my OneDrive from Canvas was this election data. So I open that up. Notice here with the Excel data, sometimes we have this goofy thing, which is, oh, the first row was the variable names. So I want to make sure I select that, hit OK. We're going to drop the old data. Now, instead of the COVID data, we've got, this is where I can't see my scroll button. There we go. Now I've got different data on, I already forgot what this was. Oh, this was like voting data, election data, right? So that's going to be kind of the basics, right? You're always going to have 3 files open. I'll give you kind of the do file for the week, and I'll usually kind of say, okay, let's click this, let's execute it, make sure everyone can kind of get it to work. But one of the key things is every file that we open up, we're going to need to have saved on our OneDrive. You can only open up files in Stata, at least the version that you're using, from your OneDrive. Okay, unless you want to go out and buy your own license, and you could open up files. I don't think you want to do that. It's a couple $1,000s, right? So that's how we're going to be kind of operating through the semester. Is kind of I'll give you a do file. We'll kind of open up these data sets. We'll then talk about different things we can code to work with that data, to calculate means, things like that. Okay. Just one more thing I would mention. If you have a data set that you're importing, so a CSV or an Excel file, a lot of the times what I'll do, so we'll go back here and I'm going to import, no, I want to get this Zoom thing out of the way, that state cigarette tax data that we originally were looking at. So I'm going to hit that. It opens it up. I'm then going to save it. All I do, I keep everything the same. So this is like my file path, right? This is where the file would exist. I'm going to save it in the exact same way. Just instead of importing it, I'm going to hit save, call it the same thing. But instead of a CSV file, I'm going to save it as a .dta. That way, instead of having to import it every single time, once I save it, now when I go to my interface, oh, what did I do wrong? Oh, it already exists. Okay, well, I'll have to add a line here and update that do file. So I think I did this before class just to make sure that it worked. What did I do here? Nope, not clear. Replace, there we go. So what I can see now, once I've saved that as a .dta file, now when I go to the interface, instead of having to go through and import these CSVs, I've saved it as a .dta file. That state cigarette tax now, I can just go to file open because it's no longer a CSV. I saved it as a .dta file. It just makes it a little bit easier to open it up moving forward. Okay. And then I can manipulate, I shouldn't say manipulate. I can add variables or I can do things to the data and then just save it as a .dta file. I don't have to worry about working with the original CSV file. So we'll do this a lot. Like I said, most often after this first week, I'll primarily just be giving you the files already as .dta. So that's really the format that we want those in. I just wanted to kind of show you if you start out with something that isn't a .dta file, you can just simply save it as one, and now that's the file that you can open up. Okay. So we'll start working with Stata more kind of next class, some different commands to create things like means. We'll talk a little bit more about distributions, how we look at distributions in Stata. Any questions just off the top here? So once again, when we're working in Stata, you really want 3 windows open. The program, your do file editor, which is where you save your code, and then you can have that browsing thing open so you can actually view the data itself, okay? So we'll work through more of this next class. Before I let you get out of here, I had something down here, so let me